Hi, everybody. So today I want to talk about how we can move to the next level in solving equations. We're going to look at questions with variables on both sides to find the value of the variable. Remember, everything is step by step, and I'm also going to show you the shortcut at the end of it all, which I think you'll probably enjoy. So let's get going here. I'm trying to solve this equation, and as I say, there's variables on both sides. Your goal is to remove the smaller of the two variable terms. 3x is less than 4x. And so I'm going to try to get rid of that first. It will avoid extra negatives at the end of it all. So what I'm going to do is draw the barrier and get rid of the 3x on both sides by subtracting it. Then, and remember to line up the equal signs. Then I'm going to try and get the x all by itself by getting rid of the negative 1, adding 1 to both sides, and that's going to give me the answer. So it's two steps because I didn't have to divide by a coefficient here. But most of the time, these wind up being three-step questions. Check your answer by plugging it in, and you can see that it gives us a true statement that 11 is equal to 11. Here's another one, same style. Remember that negative 3y is less than 8y, so I'm going to first eliminate that by adding 3y to both sides. And then I want to get the 11y by itself, which means I'm going to remove the negative 9 by adding it to both sides. And I solve by dividing by the coefficient, which tells me that y equals 1. Check the answer by plugging it in, and you'll see that that's true. Sorry for the cutoff. Okay, so it is possible that you're going to have the two terms with variables on the same side, and this actually won't be as difficult, strangely enough. Just remember to simplify both sides first. The left side, nothing changes, but the right side, you can subtract the 7x minus the 3x. And now we simply have to remove the coefficient of x by dividing 4 from both sides. X is equal to 1, same deal, plug it in, and you can see that your answer is correct. Okay, moving up another level. This one is actually going to wind up being 4 steps, maybe, because before we start anything, you're going to have to expand the brackets using the distributive property. Remember, the negative applies to both of the terms. And you're going to eliminate there's only one variable term here, so don't get rid of that. You're going to get rid of the positive 21 by subtracting 21 from both sides. Simplify that. And remember now the 7x, negative 7x, you need to divide by negative 7 on both sides. Positive 4 for x. If you plug this in, it takes a little bit more work to test it out, but it's negative 7 times 4 minus 3. 4 minus 3 is equal to 1, and so you're going to get negative 7 on both sides. Getting up in difficulty, take a deep breath. Here's what we're going to do. All right, after you draw the barrier, you're going to expand first. Get rid of all the brackets. Remember, we multiplied the 3 times both of them. Then we're going to simplify both sides by combining the like terms. Not a lot to do there, just the positive 3 and the negative 5. We want to get rid of the smaller of the two variable terms, so I'm going to subtract 3x from both sides. And now I need to get the 2x all by itself by subtracting 2 from the right side. Now don't freak out that we have a 0 there. We still do the same final step. I need to remove that coefficient on the x. So I'm going to divide both sides by 2. And 0 divided by 2 is just equal to 0. So I probably should have shown that step where I divide by 2 on both sides. All right, special case. This one's weird, okay? Pay attention. I'm supposed to eliminate the variable term that's smaller, but they're both the same size, right? So I'm going to subtract 2x from both sides and watch what happens. There's no more variable term. And look at that statement. It says 5 equals negative 3. That's never true, right? So this is actually what we call an inconsistent equation. There is no solution to it. And don't worry, you won't get this on a test, but just to say, if you make a mistake and you wind up with an inconsistent answer, something that's not true, realize you probably made a mistake. Here's another special case. We have a 2x on both sides again. And after I subtract the 2x's, I actually get a true statement. 5 is equal to 5. And because this is true, it actually means that there is a lot of values that x could be that would make this example true. There are an infinite number of solutions for x, because regardless of what you would plug in for x over here, plug in the same thing over there, and it's going to give you the same answer on both sides. Okay, so the much anticipated shortcut. You get the diagram there with the maze cutting through. Anyways, okay, so we're going to do this balancing stuff, but with a shorter way of doing it. So normally, when I would give you a question like this, you would subtract 2 from both sides, and that would be your first step. Well, using the shortcut, what we're going to do is we're actually going to slide something across the equal sign, across the barrier. And just remember that anything that's going to slide across is going to be opposite on the other side. So that positive is going to change to a negative. So I'm going to wind up subtracting the 2, and we carry the rest down, right? And usually the way I'm going to show it in my work is to put an arrow like this that said the 2 is moved across the equal sign and become a negative 2. It doesn't really save a lot of steps, but it's going to save a lot of traffic when we're doing these questions. And now I simplify the right side and divide by the coefficient. X is equal to 5. Remember, if you move a term across an equal sign, it's going to be changed to the opposite sign. That's what the big shortcut rule is all about. And it's for moving terms, okay? Moving terms. Remember, terms are added or subtracted across the equal sign. So let's take a look at this one. I got a variable on both sides. And instead of subtracting 3x from both sides and then adding 1 to both sides, what I'm going to be doing is moving the 3x across. It's going to become a negative 3x on the other side. And you bring the rest of that down. And then you can simplify the 4x minus 3x. That 3x is moved across and just joined up with the 4x. In the same way, the negative 1 here on the right side is going to move across the barrier. And it was going to be added on the other side to the 2. And that negative 1 has disappeared from the other side. There's that arrow showing that it moved across the other side of the equal sign. Now, if you get really brave, you can do both those movements in the same step in the example. And this question, you didn't have a coefficient on the x, so it was a little bit faster to get to the final answer. Okay, let's see if you can anticipate what's going to go on here. Always we draw that barrier. I'm going to be moving the negative 5y. You still want to move everything to the side which has the bigger variable term. Okay, so 8y is bigger, so I'm going to move the negative 5y over to that side. And at the same step, I'm going to move the positive 9 to the other side. So I'm going to have variables onto the left and coefficients, constants on the right. Let's take another look at that. Okay, so I got the plus 9 and the negative 5y that are both going to move. That's how it goes. All right? Notice that those two signs have changed. And so that's what the next step will look for. So actually what's going on is that 5y has moved to the other side and the positive 9 has moved to the other side in those steps. Okay, and let me erase my mess here. It moved across, it became opposite sign. And now we have to reduce the, get rid of the 13 by dividing 13 on both sides. And remember, if you don't get a nice answer, right? 7 doesn't divide by 13 evenly. Just leave it in a fractional form if it's simplified, okay? And if there is a negative on the bottom, we rewrite that negative on the top. So hopefully that's all going to be fine for you, and we'll see how this works. All right.